Hello, welcome to this YouTube presentation with the title LLMs are not enough, why broken processes still break promises in the age of AI. This video recording is based on a talk that I gave at a workshop at the SIGMOD conference, where I was invited to give a keynote to talk about the relationship between LLMs and process mining. And I will try to do that in this video. I think it will be interesting for many who are struggling, let's say, using LLMs or GenAI in an enterprise setting. And I'm happy to talk about the insights that we gathered and the experiments that we made. So of course, it's very tempting to think that AI will solve all of our problems, right? And I think more and more people start to realize that after the first surprises, things are not so easy. And so we can ask ChatGPT, for example, as an LLM. We can ask it any question and it always gives an answer. So last week I was also giving a talk at the university in Bolzano in Italy. And it was also intended for the people in the rectorate. And we were talking about how can we use process mining to improve process at a university, which of course, like an organization, like anything else. And many universities struggle with relatively basic things like reimbursing travel requests, right? I've heard it from many universities, and it's something that's very recognizable. So you can type something like this: I'm director of the University of Bolzano. It takes 6 months to process travel reimbursements. What should I do? And then, as you probably are familiar with, ChatGPT will generate pages of text. They're somehow already a bit biased based on earlier prompts that you have written. So ChatGPT suggests me several pages of, let's say, good recommendations. And at the end, it asks me, okay, shall I automatically generate a letter that the rector can send to all of the employees? And shall I generate a BPMN model? I say yes, right? So here I get a template of a letter that the rector can send. And of course, ChatGPT and all the other LLMs are excellent dealing with languages. So we get a very eloquent message. I also asked it to generate the BPMN model that it promised, and in the end it is generating something like this. And this does not make a lot of sense. So for the people that are familiar with the reimbursement process and familiar with the BPMN notation, know that this is just a picture with boxes and arrows. That doesn't mean very much. So what we see in general, and I'm using this as an example, is that on the one hand we see the promise of artificial intelligence, where super exciting things are possible and seem incredibly easy, like automatically generating documents, PowerPoints, videos, etc. It's all very impressive. But at the same time, organizations are struggling with the basic processes. And this is exactly the topic that I would like to talk about. To illustrate this, also, let's say, using my own university as an example, and my own university is currently making steps towards better supporting, let's say, their process and using process mining for this. What you see here is, let's say, one of almost 200 BPMN models that you find on the university's website. This is the process for ordering things. So this makes sense. But there are also many BPMN models that are very, let's say, compact, very simple, and they seem to deal with processes that are not, let's say, complicated at all, like getting rid of papers or ordering calendars. So what you see is that if you look at all of these BPMN models, is that they're typically pretty sequential, they're pretty simple, and they often describe the process as you would like it to see, not necessarily the way that it is happening. If you look in the university's SAP systems, then of course you can find information about what is really happening. So this is, let's say, one audit trail taken from X Suite. which is something running on top of SAP. And here you can see, let's say, the handling of the payment of a coffee break. So some of the members of my group paid for a summer school for a coffee break. And processing this took 6 weeks. It involved 16 people. And on average, each of these 16 persons was involved 3 times. So this is showing reality, right? On the one hand, we have these clean models that look very simple, and then you look at reality and you can see that it is not so simple. Of course, I'm blurring this picture because I don't want to show, let's say, names of people. Here I replaced the names of people by letters, and you can see that some people were involved 5 times, other people only 2 times. But in total, let's say over 50 activities were executed that I could find in the system. So perhaps there were more, but this is the minimum. So this is showing that reality is not so simple. And that's of course exactly the goal of process mining, to make transparent what is actually happening. And this is very important and very powerful in order to see these inefficiencies, because if you don't see them, you can also not address this. So if you look at the car factory, then the process is very visible, right? So if something is going wrong, then you probably see that the conveyor belt stops, and it is pretty easy to see where the problem is. Of course, if you're really running a car factory, you realize that it is not so simple, because there may be many external circumstances that make the conveyor belt stop, right? So for example, in times of Corona and the supply chain crisis, it could be that the car could not be manufactured completely because parts were missing, and then it's not so easy to see. But still, if you look at physical processes where you are really producing, let's say, an artifact like a car, it is relatively easy to see what the process is like. But many processes that we see that involve information and paper and services, rules, laws, these processes are not so simple, right? So you cannot walk in an organization and see the production process. So for example, every company is handling invoices, but if you walk into the building, you not necessarily immediately see where this is happening. If you go into a hospital, what you will see is you will see doctors, you will see patients, you will see beds, you will see X-ray machines, you will see queues, you will see all kinds of things, but you cannot really see what the process is. And you cannot see, for example, why it takes too long before patients can be treated, or why the bottlenecks are there at particular times in the day. So using process mining, you would like to make this visible. The approach is fairly straightforward. I will be relatively brief about this. So you extract event data from your source systems. So this could be an ERP system, it could be a hospital information system, it could be any system, and in many organizations, not one system, it's like dozens of systems that are supporting, let's say, the processes in that organization. We extract the data, but one thing that you should realize is that if you look at these systems, most of the things are recording, most of the information that you will find is recording that something has happened. So you received the payment, or you placed an order, or you gave a student a grade at a particular point in time. So event data are there, you only need to extract them, and then you can use process discovery, which is the starting point of process mining, to show what is now the real process, and you can create this transparency that I was talking about before. And so also if processes are not very physical, like a production process, you can still make visible what is happening. So where most of the time is being spent in the process, for example. This discovered process is often very different from what people expect or what people would like to see. And that is the reason that after the shock of discovery, you see something is completely different than what you would like to see. you start with conformance checking and you start to diagnose, okay, where are now these what we call execution gaps? Where is reality different from what we expect to happen? What are the root causes for this? So here we are talking about performance and compliance. And we would like to check this. If we have enough data, we can also, let's say, use predictive analytics powered by process mining techniques. And for example, we can predict how long it takes until a patient's treatment will start, right? Or we will predict that there will be a bottleneck in the production process tomorrow at a particular station. But this is only possible if you have enough data. Of course, what I'm showing you here is just diagnostics. In the end, it's of course, the goal is to change processes, otherwise this is all very pointless. So process mining is triggering what we call action flows. And this can take many forms. So you can use robotic process automation to take actions. There are these low-code workflows. So for example, Celonis has these action flows which are powered by Make, previously called Integromat. But there are many possibilities in which the process mining engine can trigger existing systems to take action. It can also be as simple as sending an email if there is a problem. But you want to make these changes that each time a problem occurs, you would like to address it immediately. That was top-down. This is a bottom-up view. So every row here corresponds to an event. This is something that has happened, right? You see a timestamp. From every event, it may be that we record many different attributes, like duration, quantity, location, and things like that. But the bare minimum that we need in order to do process mining is that for every event, we need to have a case, an activity, and a timestamp. Timestamp is easy. When did it happen? Activity is also relatively easy. What has happened? So for example, a payment was being made or an order was being placed. Order, in this example, corresponds to an order ID, an order number. But if we would go to hospital, case could correspond to a patient. If we go to university, a case could correspond to, let's say, a travel reimbursement. So these are the core things that we need to do process mining. And if we do process mining and we only look at the most frequent behavior, we typically see the happy path, right? So the ideal process. So this is the process that in a way people were mapping out in these BPMN models that I showed earlier. Of course, people, if they are really serious, they know that life is not so simple, that there are, let's say, known complications or known, let's say, sources of extra work. And you can add these kind of expected, let's say, less optimal things. So if people are modeling by hand, these are the types of models that one is making. But then you look at reality and it looks like this. So this, what you see here, is explaining why handling a travel request may take 6 months, right? It's this exceptional behavior that does not fit into, let's say, the simple BPMN model that is there, right? So if you look, for example, at the sequential flow here, you will see, I don't know, just a couple of steps, not 50, not 100. But if you look at real life process behavior, you often see loops, you see rework, you see ping pong behavior. You also see activities that are executed only in exceptional cases, but it's done very repeatedly. So reality has this higher complexity. So when people model, they tend to focus on this simple diagram. And the reason is that 80% of all the cases can typically be described by a relatively simple diagram. However, to add the last 20%, you get this spaghetti process model. So you could argue, let's take a look at the left-hand side, because this process is very simple, and let's forget about the last 20%. But that's not so smart, because in this last 20%, there are 80% of all of your problems of all of your efficiencies. They are not in this process that you've modeled. And that's why it is crucial that using process mining, you can look at everything. You can really see what's happening. And this also illustrates very nicely why transparency is very important. If you want to address that it takes half a year to handle your travel reimbursements, you need to be willing to look at reality. And then you often see in an evidence-oriented manner what the actual issues are. So to summarize, this is what we expect. When I made these slides, I was in Italy, as I was inspired by the Italian cuisine. But what you now see is here, this is what we expect. Linear, straightforward behavior. This is what we find. And the only way to improve processes is not to ignore this pile of spaghetti, but to try to understand it. What is really going on? And this is the key to process improvement. And this is necessary in order to be able to apply AI, right? And this sets the scene for coming back to let's say, large language models and GenAI. So a brief slide for the people not familiar with process mining, but I'm talking here about the connection between LLMs and process mining. So I also show this slide that basically shows the history of the field of process mining. I do not want to spend, let's say, a lot of time on this, but it started kind of as a research project in my group in Eindhoven in the late 90s, and it has evolved into, let's say, a mature scientific discipline. And so there are, if you would go to a business process management conference, half of the papers are about process mining. If you go to information systems conferences, you will find papers about process mining. There are also dedicated conferences like the International Conference on Process Mining, where this is the main topic. So what this chart shows is that, let's say, the scientific discipline matured over time with groups all over the globe working on this. At the same time, over time, more and more commercial vendors, let's say, made that technology available. And so, for example, Celonis, by far the largest process mining, let's say, company in the world, started in 2011. And this was an example also for many other software companies to follow. So lots of research, lots of available tools available, and also industry adoption. So if you look at many of the larger organizations are already using process mining. So to show that this is like not just one tool or just like a research project, this is now a mature market segment. And you can see, for example, that the Everest Group is making yearly diagrams like this to show what are the main process mining tools in this field. The same is being done by Gartner. And so Gartner creates the so-called Magic Quadrant, which is showing, let's say, the leading process mining tools in the field. In total, there are over 50 commercial offerings of process mining. You don't see all of them because companies need to meet certain requirements in terms of revenue and capabilities, etc. So it has become a mature market segment. If you look at the analysts, they say basically two things. The first thing is very obvious, like the combination of process mining and AI is becoming increasingly important with the uptake of LLMs, but also many more classical forms of AI. And another trend that I will talk about later is the fact that to handle more complicated use cases, you need to have, let's say, object-centric process mining. And it's a more sophisticated, a more natural way of doing process mining than the very simplistic type of process mining that I sketched to you earlier. So based on this, you would say, okay, this all sounds very convincing. Every organization is using it. As I said, there are already many organizations using it, but still, especially many of the smaller organizations do not have even an idea that it exists. So why is this the case? Because it's very obvious. And one of the, let's say, things that has frustrated me over the last 25 years is that when you show insights and you show what is really going on in people's processes, and there is really a problem, then people typically have the feeling that they are overloaded and they do not have any time for process improvement. And it's very important that if you apply process mining, let's say in an industrial setting, that you are aware there are two main limitations. Limitation one is data quality. Many organizations are struggling with basic things when it comes to data engineering. The other challenge is organizational change. Organizations are reluctant to change, and they really need to be forced to look at the results in order to really change something. And I think this slide very nicely, I generated this myself using ChatGPT, and it nicely shows the problem. One is overloaded, but at the same time, one is not willing to look at reality. One continues to do whatever one is doing, although process mining could help organizations a lot. So that was the process mining part. Now I would like to go to large language models, and I assume that everybody that is looking at this video has had its experiences with ChatGPT or any other, let's say, LLM that is available. Right, so these are widely adopted. I will report on some of the experiments that we did in the last couple of years, since let's say GenAI came into focus, and I should really let's say thank Alessandro Berti and Human Kurani and many others of the PATS group for, let's say, doing these experiments and driving this. Right, so this is work done by many, let's say, members of my group in Aachen. So if you think about the combination of process mining and LLMs, then of course you start thinking what are now the tasks that one is doing if one is doing process mining, and which of these tasks could be done by a GenAI. Then you can think about data extraction, you can think about discovery, you can think about conformance checking, performance analysis, detailed diagnostics, etc. And I will talk about, let's say, some of these tasks, but just to have you an idea, these are the process mining tasks that you typically see, and now we would like to apply, let's say, LLMs. Then, like a very ambitious goal could be that we try to learn LLMs by taking lots of enterprise data and create a dedicated large language model for processes. This is very, very, very resource intensive, and let's say currently very few or no people are actually doing that. Then there is fine tuning. This is also very resource intensive. But you will see that many people are already using large language models, but they take the standard large language models that are available, and they are basically doing prompting in combination with retrieval augmented generation, right? So you build prompts, but you also allow the LLM to let's say run queries, to ask questions, etc. So that's the typical paradigm. So how does this start? And so this, what you see here, is one of the first papers where we basically take an event log, we create an abstraction. So this could be a summary of the most frequent variants. It could be a so-called directly follows graph, which is a standard abstraction of your data and process mining. But you could also think of other things. So you create an abstraction, you explain in the prompt what the abstraction means, and then you ask a question. And then it's amazing that many of these, let's say, general purpose LLMs are able to give answers that sound quite sophisticated, right? So this was the starting point, and this is the naive approach. Of course, this is a highly stochastic process. It could be that you change something in your input and the answer would be completely different. Before we started to work on applying, let's say, LLMs on event data, we had this research together with my colleagues from Brazil. So the papers appeared a bit later, but this was work that was actually started, let's say, before OpenAI, etc., were released. And the basic idea here is that we try to build a taxonomy of possible questions that you could ask over event data. And so you just have event data, you make a large taxonomy of possible questions and tasks, and then using NLP techniques, you try to detect what is now the question, if it is posed in natural language, and then you call a process mining tool in order to get the answer. So this was, as I said, pre-ChatGPT, and like the results were okay, but not spectacular. But we spent a lot of time trying to look at the structure of these questions. Then a few years later, we did this experiment where we compared this rule-based approach with the ChatGPT-based approach. And also we looked at sophisticated combinations of this. And it was surprising that, let's say, the LLM-based, let's say, responses were not much worse than the, let's say, the ones that you were getting using very sophisticated techniques. So this shows that it's kind of amazing what is happening. At the same time, like the accuracy is not 100%. And there are lots of, let's say, random stochastic elements in it. So we also built tools like Promo AI, which is basically a tool that tries to use LLMs in combinations with event data and process models. So one of the starting tasks that you can do here is that you can describe a piece of text. So in textual form, you describe a process, and you ask the system to generate, let's say, a formal process model for this. If you then don't like certain aspects, you can, let's say, ask follow-up questions to repair the model, etc. It's also supporting, let's say, input in terms of event data, and it is made highly configurable, as you can see here on the slide. And so you can use different AI providers, and there's a wide range of tasks that's being supported. It also is using, let's say, a subclass of BPMN that corresponds to the Powell language that is sound by construction. Because one of the problems that you see is that if you're generating arbitrary BPMN models, that many of them are syntactically simply incorrect. So it doesn't make any sense to actually show them to users, because one knows that they are already correct. Using this approach, we are forcing the model to be in a certain format, and by which we know that there are no deadlocks, no live locks, and other types of problems. So this tool looks a bit like this, right? I already sketched it. So a typical starting point would be that you write a textual description of your process, and then you generate the BPMN model, right? And I encourage everybody to use, let's say, this tool to play with your text and to look at the BPMN models that come out of this. It also supports interactions. So if the model that is generated, you don't like it, there are certain things that you would like to see different, then of course you can make statements and you go to iterations trying to repair this. So here you see an example, right? So this is the textual description. This is in an experiment where we have a known ground truth. So we know the process model that we would like to see coming out of this. And this is what you see on the left. On the right, you see, for example, one of the models generated by one of the LLMs. So this is an experiment that you can do, and then the question is, of course, like how to evaluate this, right? If you have a known ground truth, there are all kinds of approaches that you can use to compare two process models with each other. For example, you can, there are all kinds of measures for that, but we also did experiments where we simply simulated both models, and then we looked at to what degree do these, let's say, traces that they generate look like each other. So you can do these types of experiments, and what you should be very careful about is that if the LLM is producing a very good answer, the question is, to what degree is it using the input, for example, the traces or the description, and to what degree is it using general knowledge? And here you can see, let's say, 3 examples where we have changed the order of the activities. So this is a phenomenon that you often see. If you take a process description and after creating the process description, you basically reverse it, right? So you start with the last activity and then you work your way to, let's say, the first activity. The GenAI is typically producing answers that are bad compared to that you have the activities kind of in the order that they would typically happen. And so if you look at this example and just look at, for example, the first and the last activity, you can see that sometimes the activity is the first, sometimes the activity is the last. And this is because this is a setting where we kind of randomly shuffled all the activity names. And it can be that that activity that is typically happening first, now in the description, is happening last. So if you look at the prompt at the end, there you can say just use the data, and then it will not use background knowledge, but that also defies a bit of the purpose. So what I'm trying to say with this slide is that there is this very interesting trade-off between actually just using the data, and data can be an event log or a textual description. So you just take the input and you're using as little background knowledge as possible. Or you're using lots of background knowledge, trying to fill in the gaps that are not in your textual description. And so there is a trade-off between what are you sticking to the input that you got from the user, or are you allowed to kind of fill in the blanks using background information? It can be good or it can be bad, as this experiment shows. We did many, let's say, more experiments, right? So here you can see an example of another tool, but I think you get the hang of it. Right? There are tools where you're using, let's say, general purpose LLMs to do process mining tasks. So of course, interesting to see, let's say, how these different LLM providers are, let's say, like if you compare them, which ones are the better, and can you see that they are improving over time? And especially Alessandro Berti has been super active in benchmarking these LLMs for process mining tasks. So he created, let's say, a standard benchmark composed of many different tasks distributed over these 8 categories that you see here. And he is continuously evaluating each time there is a new LLM available, a new variant. He is, let's say, rerunning the whole experiment to see how they are performing. So if you look at this slide, what you can see is that here you have the overall leaderboard, where on the top you see the best one, at the bottom you see the worst one, based on this benchmark. In total, in the collection of Alessandro, there are now 170 LLM variants. And as I mentioned, we have these 8 categories of areas where we want the LLM to do different tasks. And this results in 57 tasks. And every task is quite detailed. So typically it consists of multiple parts. So if you look at this, you have 117 LLM variants, you have 57 tasks, and you need to look at all the combinations and see which are the ones that are performing well, and that leads to this leaderboard. So just to sketch an example of a task, so here, and I will not read it all completely, but you can see at the bottom that there are, let's say, a number of questions that the LLM needs to answer. It is provided with, let's say, a fragment of event data. And here the task is look at cases where activities are happening multiple times. And if an activity is happening multiple times, try to avoid that they have exactly the same label. Try to use contextual information, adapt the name based on the context in such a way that we do not get a loop, right, where the same activity is happening multiple times. Also explain why you're doing, right? You can read at the bottom what the exact tasks are. You can see a small fragment of data. And here with the red arrows, I'm indicating the activities that are indeed happening multiple times in a particular case. So I can do that, and then I can run it over these 117 LLM variants. They all produce answers that look like this, right? So the answer, the input is text, and the output is text. And let's say this is the one that is currently leading, let's say, in the ranking. And what you then see, it is indeed able to detect these activities that are happening multiple times within the case. And it is also systematically renaming them. So that is good. The explanations and like the B, C, and D part of the question are answered, let's say, not so good. This is the worst one that we see here. So it is also generating textual output. At the end, if you look at the log that is being generated by this DeepSeek variant, like it's completely garbage, right? New cases have been created. It doesn't make any sense. It is unrelated to the assignment that we started with. So this shows that these LLMs are really, let's say, generating completely different results, and it's very fascinating to see these differences. Of course, the question is like, how do you now evaluate it, right? I say this is like a garbage log that is being generated. This is a log that is much better. So because our tasks are so diverse, and we also ask soft questions like explain why you have this particular name, we are also using LLMs to evaluate the LLMs, right? So what you see here is that the LLM variant that is currently leading in the ranking is basically evaluating itself, right? And it surprisingly it doesn't say one gets 10 points. So 10 points is the maximum number of points that you can get. So it says it's good on the first part. It is not so good on the latter part of the assignment. So this is 5.5 points. If it evaluates this DeepSeek variant, then what you see is that the scoring is very low, just 1.5. And as I said, this is very much justified. So this is fascinating, right? You can use LLMs to generate answers, and then you can use LLMs again to evaluate the answer. But it also triggers a bit the so what question, right? So this is all great. It's surprising that it works. So it's amazing, but at the same time it's confusing because it's not so clear what it means, right? You get textual results, and they are often make common sense, but they are not based on actual computations or something like that. So if you look at the early LLMs, right, the first versions of ChatGPT, if you would ask it a mathematical question, it would often give the wrong answer, right? If you would ask it to multiply two large numbers, it would give a completely random result. What you see today, if you ask an LLM multiply two large numbers or take the difference of two large numbers, it will always give a perfect answer. And that is because the LLM is calling a calculator in the background. And this makes the results very accurate. So we would like to achieve the same if we are looking at event data. And now we see how these things that I was talking about before are coming together. So we do not want this, what I showed you here, and what I illustrated kind of with all the different experiments. We do not just want to ask a question, hoping that the GenAI can generate some answers. We also do not want to show a fragment of the event log in the prompt, right? Because we can never, let's say, load the entire enterprise data in the prompt, right? That it does not work like that. So we need to do it in a different way. We need to use a more RAG style type of computation where the LLM is like not using a calculator, but is using a process mining tool to do things in a more sophisticated way. So this works as follows. So at the bottom, we have, let's say, the event data. So we will focus on object-centric event data and a process mining engine providing lots of capabilities on this event data. Also, we have a very clear description of the event data, the so-called metadata, and we can tell this to the GenAI. And so we can tell the GenAI, we have these object types, we have these event types, we have these capabilities to compute these different things. And so, for example, if there are standard key performance indicators, like, for example, what is your OTIF score, the deliveries on time in full, then there is a function to compute that over the event data. So you provide it with, these are the objects, these are the events, and these are the computations that the process mining engine can do for you. And then there is this interaction process where the GenAI, based on the question and combining it with the assets, it then poses a query. It is using the assets that are provided. Then it gets a result. And this is iterating a few times until it is able to give an answer. And now it is not guessing the answer. It is just like the calculator is now giving a real result, starting with a question in natural language. And so this is the goal. And if you look at the answer, you can always ask it to explain why it made this answer. And then it can, let's say, give the actual process mining computation that has happened behind the scene. And this is, for example, if you look at the process mining copilot of Celonis, this is exactly what is happening. So if you ask a question, for example, about your OTIF score, then you get a real number, and that number is not based on guesses, it is based on actual computations over the event data that are in the Celonis process mining engine. So this is replace the calculator by a sophisticated process mining engine if you want to apply this in an industry setting. So that is GenAI using a natural language interface to ask process-related questions. However, if you look at the relationship between AI and machine learning, there are many more connections. So a very important connection that has been around for quite a while, but that is severely neglected, is that you can also do machine learning and AI on top of event data, right? And then the only way in which you can answer questions is that you first are able to formulate the question as a machine learning problem. And process mining helps you with this. So, for example, if in the process mining analysis you see a bottleneck, based on the bottleneck, you can generate a machine learning problem trying to explain why it is there or even to predict it is there. So this applies to predictive AI, prescriptive AI, where you use AI to automatically take actions. But this is also the connection to classical operations research and classical machine learning approaches that are there. I think it's a missed opportunity. Lots of focus goes now to LLMs. At the same time, this part is a bit neglected, typically because organizations are missing this process-centric view on the data, which makes it very easy to pose such questions. This is illustrated in this, let's say, screenshot of Celonis. So once you have your object-centric process mining results and you see a deviation, you see a bottleneck, you see a decision that you would like to understand better, then you can automatically generate machine learning problems. And so we use the term situation tables here. And based on these situation tables, we are training classifiers that can be used to explain why is there this bottleneck, why is there this deviation, but we can also predict it in the future based on historic data. So this is the part that is there. Then we can kind of look a bit further, right? What are other areas where these new developments involving LLMs and GenAI can help? I think a very interesting area is how to extract event data from your source systems. As I said earlier, the two big hurdles for organizations to apply process mining successfully is that they have difficulties with organizational change. That's one part, resistance to change. We are too busy, we cannot do process mining. The other part is, let's say, issues related to data engineering. And GenAI can help definitely there. Also these days, many people talk about intelligent agents. That's similar to what I referred to earlier as action-oriented workflows. It is also related to RPA. And this is this desire to not just do diagnostics. No, you would like autonomous active behavior. So to answer certain questions, to do certain tasks. And I'm using a very important word, that is context, right? I hope what I showed so far is that you can only give a meaningful answer if you provide it with the context that is actually important for a particular decision or for a particular action. And using like these event data and these process mining capabilities, they are essential in order to be able to do this. If it's just based on internet knowledge and a textual prompt, it will never work. So we are moving from an LLM using a calculator to an LLM also using a process mining tool. And this is something that is very, let's say, essential and crucial to look at the successful combination between GenAI and process mining. As I mentioned, context is everything. And in the beginning, to introduce, let's say, process mining to people that did not see it before, I talked about case-centric process mining. So we talked about events, and every event was referring to precisely one case, right? And it sounds very logical when I showed you that. You also saw process diagrams which were clearly showing the flow of cases. And this could be very simple, or this could be very spaghetti-like. Now, we want to go one step further, because this is not enough, right? If you look at events, it involves more than a single object. And if you look at the database system, you will see that the database system is actually talking about lots of different objects: suppliers, customers, invoices, orders, products, items, employees, etc. So context is everything, and therefore we enrich this event notion where we replace just one case by any number of objects. And object sounds very abstract, but you can use it for everything, right? So it can be customers, suppliers, invoices, machines. In a hospital setting, this could be, I don't know, things like appointments. It can be doctors, X-ray machines, treatment plans, etc. So an event is something that happens. It is an activity that is the what, the timestamp is the when, and the object is basically everything that is involved with this. And this is very crucial, right? So for example, if you look at the production of a car, I think everybody understands that that when you order a car, this is not a linear case, right? Before you order the car, people are already producing parts of the car. So the car is made to your specification, but for example, the brakes or the engine may have been manufactured already a long time ago. So this shows that the events and the activities involved in such a process do not involve just one case. It is much more. So that's why we are using this colored spaghetti to show like it's not just one thing, one case. It is much more. It is involving people, machines, parts of the car, etc. Another example, this is one of my favorite examples. So for example, Lufthansa is a Celonis customer. It is using process mining in various areas, including trying to minimize delays. If you look at the events that are happening when the plane lands, for example, in Frankfurt or Munich, and then takes off again, often within 1 hour after landing. What are the events that are happening, right? So, of course, you need to unload the baggage, you need to load the baggage, people need to leave the plane, new passengers need to board the plane. The plane may be refueled. There are also people standing at the gate. The people that are standing at the gate may have been people that were standing at the check-in desk before. The plane may need to be refueled. So these are just examples of things that are happening. And what you hopefully see is that there are many events, but these events are also involving different objects. So the number of suitcases that go onto a plane correlates with the number of passengers, but one passenger may have no suitcases, another passenger may have 3 suitcases. So these are showing the reality, and you cannot reduce it to a single case. I cannot say, okay, we just have a plane landing, taking off, and these things are happening. What you then see is also a fairly random sequence of events if you don't see this structure. So context is everything, and this is key for applying generative AI. To make it simpler and to show an example that you can more easily relate to is, for example, the standard example where we look at buying items, and these items are delivered after some time. So what this slide sketches is 2 orders. Each of these 2 orders consists of 3 items. It can be that these items are delivered in the same package 1 day later, but it can also be that there are items that have a longer delivery time and arrive later. So it can be that in one package there may be items of multiple orders, and at the same time, if you view it from an order, if you place an order, like the items do not come into one package, they may be scattered over multiple packages. So this is a reality. So if I now try to describe this process, then I need to make a choice. If I'm doing case-centric process mining, I look at the orders, I look at the items, or I look at the packages. If I do that, I get these siloed processes that are very misleading because you cannot see the interactions between the different objects. So in blue, you see the handling of orders. So you can see an order is placed, confirmed, there may be 1 or more reminders, and finally the order is paid. If you look in red, you see the flow of items. If you look in green, you see the flow of packages. What you should also note is that if you look at, for example, activity place order, this is involving both an order and an item. So I see it when I take the case-centric view of items, I see place order happening 8,000 times. If I look at the blue flow, I see it happening only 2,000 times. However, we know that in reality, place order happened 2,000 times. But in one order, there can be multiple items, and that's why the frequency in the green part is higher. You can also look at, let's say, the last activity package delivered. So how often does that happen, right? And it depends. You can look at the package, but you can also look at the items in it, right? If we have 8,000 items, it is happening 8,000 times, but the number of packages is much smaller. So this is showing the problem that if you force this data into a case-centric view, you get very easily distortions and numbers that do not make any sense. So if you do object-centric process mining, you discover object-centric process models that look like this, where you see the flow of the different objects into, let's say, a common process model. And if you look at the numbers, for example, place order is happening 2,000 times, these are the real frequencies. But the double-headed arrow is showing that in one place order event, there may be multiple items involved. And if you're using, for example, Celonis as a process mining tool, you can now drill down on this data, and you can see what is now the distribution of the number of items that is involved in an order. So in other words, we get a very accurate, integrated view of reality. So the Slowness, let's say, platform completely, let's say, supports this object-centric view on the data and processes. So when loading the data, you are not loading cases, you're loading objects and events. You can do discovery, for example, using the multi-objects process explorer. You can do conformance checking, you can do performance analysis, you can use directly follows graphs, you can use object-centric BPMN models. And so this is supporting this whole spectrum. And if you look at compliance or performance problems, you can look at all of these different objects and their interactions at the same time, right? So here, for example, you see the PAM tool of Celonis, where you see a frequent deviation, and you can drill down on what this actually means. You can also look at things like, for example, the OTIF score, right? So there, an order is placed, and when is the last item of the order actually being delivered? These are the types of questions that involve multiple, let's say, object types. And so if, for example, you're a company and you have difficulties, let's say, supplying your customers in time with the things that they have ordered, it can be in sales, it can be in production, it can be in procurement, it can be in logistics. And you need to look at the bigger picture in order to really see what the root causes are of certain problems. And object centricity is crucial in doing this. So using object-centric process mining, using object-centric event data, you create this view on the process, and that view is rich enough to apply machine learning techniques on top of this, and you provide the context that is actually needed to answer these types of questions, right? So this is like the take-home message. You can use LLMs, you can use AI, you can use machine learning, but you need to provide it with context. Of course, this is not the message that many people, like in practice, would like to hear, right? They believe in this shiny new world of generative AI, where you just ask questions and there are agents doing all of the work. But in reality, this cannot work if it is not based on actual data, right? So if you look here on the right-hand side, this is the object-centric event data that you need to collect, need to be sure that that is of good quality in such a way that you can actually, let's say, make this LLM or this agent give you the results that you would like to see. So this illustrating mind the gap. Like I feel that the gap between what is really happening with organizations having difficulties, I don't know, paying travel reimbursements in time, or helping citizens. So for example, there are now incredible delays for people needing to get like a driver's license or some permit or something like that. It shows the gap between reality, where we talk about the shining AI world, where reality is very different, and that is because we are not dealing with text, we are not dealing with images, we are not dealing with funny videos, we are dealing with processes, and that's why you need to take this very serious. So to conclude, I hope I showed for the people that are new to this that process mining is an interesting, mature technology that is not on the radar of many, let's say, people and many organizations. That's a pity, because it is something that works. If it doesn't work, typically the reason is that organizations have data engineering problems, right? They do not know the data they have, or the data is of very low quality, or they have difficulties accessing it, or they have difficulties with organizational change, right? They do not want transparency because it will show certain things that people do not want to show. Sometimes I say process mining, right, if it doesn't hurt, there is no problem, right? So if you make things transparent, you have to realize that this is not always nice for everybody involved. And this is very important, but it shows organizations that want to be successful, organizations that want to renew themselves, they really need to embrace this technology to get this transparency that is needed. I also showed you several, let's say, experiments with large language models in combination with event data and processes. And I hope that this shows, let's say, what is the state of the art, what do these general purpose LLMs do. And the take-home message there, it is surprising, it's amazing what these general purpose LLMs are able to do. At the same time, it's also a bit inconclusive. And that's why in the last part, I focused on a more systematic way of doing this, where you provide the GenAI and the large language models with very accurate object-centric event data and the capabilities of process mining in such a way that you can give, let's say, answers in a more reliable way. And this is just like the LLM in the past was not using a calculator in the background when it was asked a mathematical question. LLMs of the future should not ask, so if you ask it a process-related question, it should want to get the process-related data and have the process mining capabilities, let's say, underneath it in order to give a meaningful answer. And this is very much possible in the way that I sketched it. Thank you very much.